Hello friends, today's question. A metal ball immersed in alcohol weighs W1 at 0 degree centigrade and W2 at 50 degree centigrade. The coefficient of cubical expansion of the metal is less than that of alcohol. Assuming that the density of metal is large compared to the alcohol, it can be shown that, so we have to make a comparison between the weight of the ball when it is immersed in alcohol at a temperature of 0 degree and when it is immersed at the temperature 50 degree centigrade. Okay, which one is W1 or W2? We are going to make a comparison between them. So there are two important terms which will be associated as soon as we can say with respect to metal ball, alcohol, and coefficient of cubical expansion. First is, you can say, is the buoyant force. First is the buoyant force. So buoyant force can be, you can say, affect the weight of the metal ball as soon as it is immersed in the alcohol, and because the buoyant force is going to push the metal ball in the upward direction, and the buoyant force depends upon the volume of the displaced alcohol. Okay, so you can say that weight of the metal ball when immersed in alcohol will be affected by the buoyant force, will be affected by the buoyant force, which depends upon the volume of the displaced alcohol, which depends on the volume of alcohol displaced. Then the second is called as a thermal expansion. So thermal expansion is nothing but temperature dependent. So both our metal ball as well as alcohol is going to expand when the temperature increases. Okay, and with respect to thermal expansion, there is a term which is called as a coefficient of cubical expansion, or sometimes it is also called as a volumetric thermal expansion. So you can say both metal ball and alcohol expand when temperature increases. And the other term which is associated is called as a coefficient of cubical expansion. Coefficient of cubical expansion. It can be also called as a volumetric thermal expansion. Volumetric thermal expansion. So it determines how much the volume of the substance increases as the temperature changes. It determines how much the volume of substance increases with change in temperature. With change in temperature. And in the question it is given that the coefficient of thermal expansion of the metal is less than that of the alcohol. So you can say that coefficient of cubical expansion for metal is given as gamma metal, is taken as rather gamma metal, and for alcohol it is taken as gamma alcohol, ALK in the shorter form. And it is given that the coefficient of cubical expansion for metal is less than that of alcohol. So from here we can frame that coefficient of, you can say, gamma metal is less than gamma alcohol, and this is given to us. So from here we can draw one conclusion, that alcohol expands more than the metal, and it is also given that the density of metal is more than the alcohol. Okay, so from here we can draw a conclusion that alcohol expands more than metal, and it is also given that the density of density of metal is large as compared to alcohol. Density of metal is greater than density of alcohol, and this is also given. So we have to make a comparison between the temperature 0 degree centigrade and temperature 50 degree centigrade. So let us start with the temperature at 0 degree centigrade. When temperature is 0 degree centigrade, the weight of the ball immersed in the alcohol, weight of metal ball immersed in alcohol, let us suppose that is given as W1, and that will be equal to W metal minus the buoyant force at 0 degree centigrade buoyant force at 0 degree centigrade. Here W metal is our true weight, that is equal to mg, and W1 is our apparent weight. So let me write it. W1 is our apparent weight, W metal is our true weight. And the buoyant force at 0 degree centigrade, we can write its formula. We can say that buoyant force at 0 degree centigrade, buoyant force at 0 degree centigrade will be equal to volume of the metal multiplied by density of the alcohol and multiplied by G. And let us say that the mass of the alcohol is given as mLK, okay, because we are going to convert this density in terms of mass and volume. Okay. So you can say that mass of alcohol is given as MALK, which will be equal to, which gives that density of alcohol will be equal to mass of alcohol divided by volume of alcohol. Now let us do the same calculation at 50 degree centigrade, when temperature is 50 degree centigrade, and we can write that W2 will be equal to our W metal, that is true weight, minus, and then we can use a standard formula. We are going to convert this V metal from 0 degree centigrade to an expanded version of at a temperature of 50 degree centigrade, and similarly we are going to write this rho alcohol in terms of the mass and volume at a 50 degree centigrade. So this will be coming as V metal 1 plus, here we have rho metal multiplied by temperature difference 0 and 50, so temperature difference is 50, and here we can write mass alcohol divided by volume of alcohol, and same formula that we get this as rho alcohol at 50 degree centigrade. Okay, so this is the basic formula. And this is delta T, initial temperature is 0 degree, find another temperature is 50, so difference come as 50. So let us write next. Now it is quite simple calculations, not much of the things left now. So we found out that our W1, let us substitute the value of, this is our W1, so we are going to substitute the buoyant force by this formula, rho metal V metal rho alcohol G, and similarly W to this, and make a comparison between the two. So we get W1 is equal to W metal minus, we get V metal, and for density we can write as M alcohol multiplied by G and divided by V alcohol, and W2 we found out is equal to W metal minus, we get this as V metal, and at a temperature of 50 degree centigrade, so this will be rho metal at 50 multiplied by M alcohol divided by V alcohol, and this is 1 rho alcohol, and once again 50 and multiply by G. So here we assume that this entire term is F1 and this entire term is F2. So we say let F1 is equal to V metal and mass of alcohol multiplied by G divided by V alcohol. Therefore, we can write that W1 will be equal to W metal minus F1 and F2 is our V metal mass alcohol multiplied by G divided by volume alcohol, and here we can write 1 plus rho metal divided by 50 multiplied by 50 divided by rho alcohol and multiplied by 50. Therefore, we can say that our W2 is equal to W metal minus F2. But it is given that our density of metal is greater than density of alcohol. Okay, it is given the density of alcohol, density of metal is greater than density of alcohol. So we are given that density of metal is greater than density of alcohol. Okay. Therefore, so it means from here we can write, and also it is given that coefficient of cubical expansion, that is gamma metal, is less than gamma alcohol. So these two terms are given. Therefore, we can write that if I divide F2 by F1, we get this as 1 plus rho metal multiplied by 50 divided by 1 plus rho alcohol one second, sorry, there is a mistake on my part. I wrote the entire formula wrong. Here it should be gamma, okay, not density. Sorry, this is gamma, this is also gamma, okay, and here also it should be gamma, here it also should be gamma. My apology for that. And it should be also gamma, a thermal expansion. Okay, I just made a mistake by writing it in from the density. This is gamma and this is also gamma. Okay, anywhere else I made a mistake. I think this is the only formula. I think now it's correct. Okay, so please make sure, if any case if I miss somewhere, this should be our gamma, coefficient of expansion, cubical expansion, not density. My mistake. Here also, because we are mainly interested in this part. Okay, so this comes our less than 1. Okay. This will be our less than 1, and therefore here we can say that F2 is less than F1. Okay, F2 is less than F1. So let us rewrite these two equations, equation number 1 and equation number 2. We are going to make comparison between equation 1 and 2 based on this equation. Let us suppose this is equation number 3. So let me write it once again here. Omega 1 is equal to W metal minus F1, and we have W2 is equal to W metal minus F2. So we have to make a comparison between the apparent weight W1 and W2, and we drew a conclusion that F2 is less than F1. Okay? F2 is less than F1. So if we make a comparison that our F2 is less than F1, so it means the negative part in 1 and 2, negative part in 2 is less. Therefore, automatically, if negative part in 2 is less, that is W2 will be more as compared to W1. From here you can say in equation 2, negative part, that is F2, is less. Therefore, you can say W2 is greater than W1. So the final conclusion is that apparent weight of metal ball when the temperature of the alcohol is 50 degrees centigrade is more than the apparent weight of the alcohol when the temperature is of the So we can say that W2 is the apparent weight when the temperature of alcohol is 50 degrees centigrade, and W1 is the apparent weight when the temperature of alcohol is 0 degrees centigrade. So this is apparent weight at 50 degrees centigrade, and this is apparent weight at 0 degrees centigrade. So if we see the options that are available to us, you can say that W2 is greater than, in the answer it is written like this, W1 is less than W2. You can say option number C is the correct option. C is correct. Okay. So I am sorry for the oversight regarding the formula. It should be the thermal expansion, sorry, cubical expansion. So everywhere it should be gamma, not rho. Okay, that's my mistake. I'm sorry for that. Thank you.